Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about numerical problems on the high calorific value and low calorific value of the fuel. So what is meaning of fuel? So during combustion process, fuel is a combustible substance. During combustion or burning process in the presence of oxygen, it produces heat energy. Is called fuel. So this process is called combustion of fuel or burning of fuel in the presence of oxygen. So in this case, it produces heat energy. So the efficiency of fuel, it can be understood by its calorific value. So calorific value is the most important in these fuels. So calorific value means the how much amount of heat liberated when a unit mass of fuel is completely burned. Unit of mass of fuel means 1 kg or 1 gram or 1 part. So how much amount of heat liberated when a unit mass of fuel is burning. So this process is called combustion. So here how much amount of heat liberated, that is called calorific value of fuel. So the efficiency of fuel, it can be understood by its calorific value. So there are two types of calorific values, high calorific value and low calorific value. Already we discussed detailed study of calorific value in previous classes. Now today's session is problems based on this LCV and NCV. So what is the meaning of calorific value? How much amount of heat liberated when a unit mass of fuel is burning. That is called calorific value. So there are two types of calorific values, high calorific value or low calorific value. So high calorific value, it is also called as gross calorific value. So it can be defined as the amount of heat evolved or how much amount of heat liberated when a 1 unit mass or volume of fuel is completely burned and combustible products are cooled at room temperature. So in this, how can you define this HCV, high calorific value? So it is defined as how much amount of heat liberated when a unit mass of fuel is burning. And also we consider latent heat of vaporization of water. That means combustion products are cooled at room temperature. So in this case, the temperature, that evolved temperature also we can consider. So that is called latent heat of vaporized water. So in this way we can calculate HCV equal how much amount of heat liberated plus latent heat of vaporization of water. Latent heat of vaporized water. So this is also we can consider. So what is meaning of NCV or lower calorific value? So it is defined as the amount of heat evolved when a unit mass or volume of the fuel is completely burned. So here net calorific value, that means we can consider only how much amount of heat liberated. We consider that heat only. We cannot consider latent heat of vaporized water. So in that case, net calorific value is equal HCV minus latent heat of vaporized water. So we consider in this case net calorific value, we consider only how much amount of heat liberated when a unit mass of fuel burn. But in HCV, we consider latent heat of vaporized water and also how much amount of heat liberated. So these two considered in this HCV, but NCV we considered only how much amount of heat liberated. So in this problematic purpose, most important formulas or gross theoretical calculation of calorific value of fuel is GCV according to Joulang's formula. So Joulang's formula for theoretical calculation of high calorific value and low calorific value. So high calorific value, it is also called as gross calorific value. So it's equal 1/100 into 8080 carbon plus 34,500 H minus O by 8 and 2,240 sulfur kilocalorie per kilogram or calorie per gram. And NCV equals HCV minus 9 by 100 H into 587 kilocalorie per kilogram. These are the main important formulas for the theoretical calculation of calorific values of fuel. So here in this gross calorific value, here 8080, 34,500 and 2240, it indicates that theoretically the calorific values of carbon, hydrogen and sulfur when 1 kg of fuel is burning. We can assumption that the calorific value of carbon is 8080 and hydrogen is 35,500 and sulfur is 2240 when 1 kg of fuel is burning. And here these elements carbon, hydrogen, oxygen, sulfur, this indicates how much percentage of these elements present in fuel. And next NCV or LCV, it's equal HCV minus 9 by 100 into H. Here H means percentage of hydrogen present in fuel. Percentage of hydrogen present in fuel and into 587. This 587 is a theoretical calculation of latent heat of vaporization of water formed. So its value is 587 kilocalorie per kg. So these two formulas are most important for calculation purpose for determination of high calorific value and low calorific values of fuels. Now let's discuss numericals based on HCV and LCV. So calculate the gross and net calorific values of fuel having following composition. So what is the composition given in this formula? Given in this numerical, carbon percentage is 82 and hydrogen percentage is 8% and oxygen is 5% and 2.5% of sulfur and 1.4% of nitrogen and 2.1% of ash. So given in this data, so now you can calculate the high calorific value and low calorific value of the fuel. So here GCV equals, what is the formula? Just we discussed already. How can you calculate the gross calorific value? So by using this Dulong's formula for this gross calorific value. So the formula is GCV equal 1 by 100 into 8080 carbon and 34,500 H minus O by 8 and 2,240 sulfur. So here this carbon, hydrogen, oxygen, sulfur, these elements indicates that how much percentage of these elements present in fuel. So given in this data, so carbon percentage is 82, hydrogen percentage is 8, oxygen is 5 and sulfur percentage is 2.5 and nitrogen percentage is 1.4 and ash percentage is 2.1%. So substitute all the elements percentage in this above formula. So now we'll get 1 by 100 into 8080 into carbon percentage is 82. We can substitute here and 34,500 into H, hydrogen percentage is 8 minus oxygen percentage is 5 by 8 plus 2,240 into sulfur percentage is 2.5%. So we can substitute here sulfur percentage 2.5. So finally after calculation we will get gross calorific value of given fuel is 9,225.97 calories per gram. Calorie per gram. Now we can calculate the net calorific value. So what is the formula? NCV equals GCV minus 9 by 100 into H into 587. So here H is the how much percentage of hydrogen present in fuel. 587 is the latent heat of vaporized water. So here gross calorific value, just now we calculated already here. So gross calorific value is 9,225.97. We can substitute here minus 9 into hydrogen percentage present in fuel is 8. So we can substitute in this 8 by 100 into 587. So it's equal 8803.3 calorie per gram. So in this way we can calculate the high calorific value and net calorific value by using this Dulong's formula for high HCV and NCV. Now let's discuss one more problem. So the percentage composition by weight of sample of coal is given as below. So here carbon equal 70%, hydrogen is 6%, oxygen 22, sulfur 2% given in this data. So using Dulong's formula, calculate the calorific value of coal. So already we know that what is the Dulong's formula for this calculation of high calorific value and low calorific value. So gross calorific value or high calorific value, it's equal. What is the formula we can use here? 1 by 100 into 8080 carbon plus 34,500 H minus O by 8 plus 2240 sulfur calorie per gram. This is a formula used for the determination of the high calorific value of fuel. So now we can substitute the percentage of carbon, hydrogen, oxygen, sulfur, whatever given in this data in this problem. We can substitute the values in this formula. So now we'll get 1 by 100 into 8080. Carbon percentage given in this data 70. So we can substitute here 70 plus 34,500 into hydrogen percentage is 6. So 6 minus oxygen percentage is 22. So we can substitute hydrogen oxygen percentage here 6 minus 22 by 8 plus 2240 into 2. 2 means here sulfur percentage present in this fuel calorie per gram. So after substitution, after calculation, we'll get final value of gross calorific value of given fuel is 28,514. 28,514.5 calorie per gram. This is the gross calorific value of given fuel. Now you can calculate the net calorific value. So NCV it's equal GCV minus 9 into H by 100 into 587. This is the formula used for the net calorific value of the fuel. Here hydrogen is the percentage of hydrogen present in fuel and 587 is the latent heat of vaporized water. So it's equal gross calorific value of given fuel is 28,514.5 minus 9 into percentage of hydrogen present in fuel is 6. So 6 we can substitute here and by 100 into 587 or multiple with 587. So finally we'll get 271, that means 27,185.55 calorie per gram. So in this I can calculate the gross calorific value and net calorific value of fuel. Now let's discuss one more problem that is based on that high calorific value and low calorific value. So here calculate the net and gross calorific value of coal sample having following composition. So here carbon equal 82% and hydrogen equal 8% and oxygen equal 5% and nitrogen equal 1.4 and ash equal 3.6%. But in this problem, it given we have only carbon, hydrogen, oxygen, sulfur percentages only. But here it given already nitrogen and ash also. But if in case nitrogen and ash present in fuel, these nitrogen and ash doesn't have any calorific value. That means these values are undesirable. If in case these elements present in fuels, it is undesirable. Because if in case nitrogen present in fuel, it reduces the calorific value. And the same way, if in case ash present in fuel, during burning process it produces ash. So if in case this percentage increases means it reduces the calorific value. So this if in case ash present in fuel, that is also undesirable. We cannot consider here. So these two are undesirable. So in this formula we can substitute only the percentage of carbon, hydrogen, oxygen and sulfur. So here sulfur data is not given here, so we can take here 0. So now we can calculate the gross calorific value and net calorific value of given fuel. So gross calorific value is equal 1 by 100 into 8080 carbon plus 34,500 H minus O by 8 plus 2240 sulfur calorie per gram. This is a formula used for the determination of gross calorific value. So we can substitute the percentage of carbon, hydrogen, oxygen, sulfur in this formula. So here, according to given data, so carbon percentage is 82, hydrogen percentage is 8, and oxygen is 5, and sulfur not given here, so we can take here 0. So we can substitute all these values in this above formula. Now we'll calculate after that multiplication, we'll get 1 by 100 into 6,62,560 plus 2,54,437.3 calorie per gram. This value is the 0. So after calculation, finally we'll get gross calorific value of given fuel is 9,169.8 calorie per gram. So now we'll calculate the net calorific value of fuel. So what is the formula for calculation of gross net calorific value or low calorific value? So NCV equals GCV minus 9 to H by 100 into 587. So here GCV, gross calorific value, just now we calculated. So what is the value of gross calorific value of given fuel? 9,169.8 minus 9 into or 9 by 100 into hydrogen percentage is here 8 percentage. So we can substitute in this formula 8, 9 by 100 into 8 into 587. So it's equal 8,747.34 calorie per gram. So gross calorific value of given fuel is 9,169.8 calorie per gram and net calorific value of given fuel is 8,747.34 calorie per gram. And one more problem based on the same LCV and NCV. So here the percentage composition by weight of the sample of coal is given below. So the carbon percentage in this fuel is 65.5. Carbon percentage in this fuel is 65.5 percentage. Hydrogen 6.65 percentage. And oxygen 17.5 percentage. And sulfur 1.8 percentage. So using Dulong's formula, calculate the calorific value of a coal. So what is the Dulong's formula of gross calorific value? So according to Dulong's formula for theoretical calculation of gross calorific value of fuel is, formula is GCV equal 1 by 100 into 8080 carbon plus 34,500 H minus O by 8 plus 2,240 sulfur and calorie per gram. So here in this formula, here 8080 is the, we can assumption that for theoretical calculation, we can assumption that calorific value of carbon is 8080 and hydrogen is 34,500 and 2,240 is the sulfur calorific values. We can assume that. So now this elements carbon, hydrogen, oxygen, sulfur, this indicates how much percentage of these elements present in this given fuel. So in this data given that carbon percentage is 65.5. So we can substitute here carbon percentage is 65.5 plus 34,500 into H minus hydrogen percentage is here 6.65 percentage. So we can substitute here 6.65 minus oxygen percentage is 17.5. So we can substitute in this 17.5 by 8 plus 2,240 into sulfur percentage is 1.8. 8 given in this data. So we can substitute all the elements, that means carbon, nitrogen, oxygen, sulfur, how much percentage present in this given data. So we can substitute all these element percentage in this above formula, in this Dulong's formula for high calorific value of given fuel. So after substitution, I'll get 1 by 100 into 5,29,240 plus 46,790.625 calorie per gram. So after calculation, finally you'll get gross calorific value of given fuel is 52,083.025 calorie per gram. And next you can calculate the net calorific value. So how can we calculate the net calorific value of fuel by using Dulong's formula? So what is the Dulong's formula for lower calorific value of given fuel? So it's equal NCV equal GCV minus 9 into H by 100 into 587. So GCV, gross calorific value of given fuel, is 52,083.025. So substitute here GCV value minus 9 by 100 into H. So here H is the percentage of hydrogen present in fuel. That's value is 6.65. So we can substitute in this formula 6.65 percentage of hydrogen present in given fuel into 587. This 587 is the latent heat of vaporization of water formed. So after calculation, finally we'll get lower calorific value of given fuel, that is a 51,731.7055 calorie per gram. So in this way, you can calculate the gross calorific value and net calorific value of given fuel by using Dulong's formula. So these two formulas are most important for theoretical calculation of high calorific value and net calorific value of given fuel. So today's session will learn about high calorific value and low calorific value. What is the definitions of these two, high calorific value and lower calorific value, and Dulong's formulas and theoretical calculation of Dulong's formula for the lower calorific value and high calorific value. So by using this formula, we can calculate the low LCV and HCV that are given in this data. Numericals will discuss based on that HCV and LCV. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.